Okay, for science today, we are learning a little bit more about the four forces of flight, and I'm guessing that you probably have ideas of maybe what they are. Yeah, so yesterday we did a lot on lift and gravity, and then today we're going to mainly focus on one of the other forces. Okay, so here we go. All right, so the four forces at work. We know lift is the upward force, gravity is the downward force, thrust. This is mainly what we are focusing on today. So thrust, I guess whichever way you want to draw it within your own initial page we did, go for it. Thrust is the forwards force, okay? And then drag is the backwards force. So we're going to be talking about drag next week, but for now we're just going to be talking about, today we're going to be talking about thrust. Okay, and then drag is the resistance on the air of the wings, the plane's wing and body, but we're going to be doing that more next week. Okay, so hopefully you have some space for the thrust section. Okay, so again here from NASA, so this is just showing the forces again, okay? So lift, yeah, okay, so lift and the weight have to kind of be balanced, and then thrust and, okay, so right, they call it lift and weight. I guess weight would be the same thing as like the pull of gravity depending upon the weight. And then thrust and drag, those are the opposing forces, okay? So opposing, opposing. Obviously, in order for there to be flight, which forces need to be the strongest? Lift and thrust, right? If drag and weight are heavier, then the plane's not gonna go anywhere. Okay, great. All right, so force number one is lift. Oh, we did this already. Okay, yeah. So lift is, we don't have to write any of this down. Lift is the upward force that causes the plane to rise. It opposes gravity. The wings are the main part of the airplane that allow lift to be possible. Yeah, that's right, because they're shaped in this aerofoil design and they create, well, because of the air pressure, right? We have still air or slower moving air underneath, which has high pressure. And then we have this pocket of low pressure created above the wing by the fast movement of the air. Okay. Cool. All right, and then gravity, we already did this. Gravity is the downward pulling force. It opposes lift, and then gravity pulls objects in a downward direction. Okay, you don't have to write any of that down. We know that. That's review. Okay, new stuff today is thrust. All right, so thrust is a forward pushing force. It is the force that opposes drag. Okay, yep, so I guess you don't have to write any of that down because we already have that. Okay, so the amount, you should write this down. The amount of thrust is related to the force produced by the propeller or the jet engine. So of course, if it's a more powerful plane, like a jet compared to a propeller, then there's going to be way more force that is like basically shoved, like the air is being shoved even further and faster behind the plane to cause it to move in the opposite direction, which would be forwards. Okay, so, oh yeah, that's one more thing. Okay, so the propeller, you don't have to write this down, but it's just like, you'll just take note of it. The propeller has a similar shape to that of the wing. And as it spins, it creates a low pressure zone on the front surface of the propeller related to the increase of the airspeed there. So here, as it spins, the airfoil would be on the top part of the blade of the propeller, and as it spins, it's creating this low pressure, fast moving air on this side, which is going to pull the plane forwards in towards that pocket of lower pressure, being pushed by the still air, which has high pressure behind it, which is kind of cool. All right, so this causes the propeller and the attached plane to move forward. Okay, so you don't really need to write that down. The most important thing, I guess, is the amount of thrust is related to, the power or the force of the engine. Okay, kind of obvious though. Okay, this is cool. You do not need to write this down, but it's just like, a little bit of extra stuff going into like when you guys get into doing physics later. So thrust is relating to Newton's third law of physics, which states, for every action, there is an equal and opposite reaction. So yeah, so for every action, which would be the backwards motion of like the propeller that's pressing on the air, the opposite and equal reaction would be the movement forward. So both the propeller and the jet engine drive air behind the plane, right? So that's the action, and then the reaction would be the forwards movement of the plane. You don't have to write this down. It's kind of just like, yeah, just kind of watch and hopefully it kind of makes sense. So the air movement is the backwards action, of course, which causes the forward thrust. Okay, now this is the same thing for when we're going to be creating our paper airplanes. So basically these are the different forces of thrust, right? What is creating it? So a propeller, a jet engine, right, is pushing forward, and then thrust of your hand is the forward motion as well. So all of those things would count, or even like a slingshot would count, or like pressing off of something. If you're like leaping off a diving board, that would also count as thrust, anything that's like a forward motion. So the reaction is a forward force exerted on the airplane. Okay, so basically thrust, forward force, that's kind of the main thing, but we kind of already get that. This forward force is called thrust, which moves the airplane forward. Yep. Thrust can be increased by shoving more air backwards with a greater speed. Same kind of deal, right? Like, of course, you know you're going to throw a baseball harder if you are increasing the speed. If you're shoving, you have more muscles. You're shoving that baseball with a further strength. Okay. You don't have to write any of that down, though. It's just sort of explaining it a bit further. Okay, so we're going to watch a video in a second here. So in flight, lift, okay, which we did yesterday, and weight, so gravity, play a tug-of-war role, meaning that they work in opposition. Yeah, okay, you don't have to write this down either. This is sort of the same stuff. So if the force of lift is greater than the weight of gravity, then the plane rises. Okay, of course, the force of lift has to overcome the force of weight of gravity. So if the weight of gravity is greater than lift, then the airplane will fall or stay on the ground. So of course, if there was like a bit of a problem in the air with the airplane and suddenly the lift isn't being created, then you got it. Gravity is going to take over. All right, just like what happened in Explorers. Okay, here we go. We're gonna watch this.
Have you ever sat in the seat of a jumbo jet and wondered how it's able to fly through the air while loaded with passengers, cargo, and fuel? Let's take a closer look at how a wing is able to lift airplanes both large and small off the ground. As an aircraft's wing slices through the air, it pushes air over its top and under its bottom surface. A wing's curved shape is designed to cause air to move at a higher speed over its top surface compared to its bottom surface. A principle in physics states that faster moving air has lower pressure than slower moving air, meaning that there's more pressure on the bottom of the wing than on the top of the wing. The higher pressure air pushes up on the bottom of the wing, and the result is lift. The angle of the wing relative to the air that it slices through, called the angle of attack, also contributes to the wing's lift. A wing at a higher angle of attack generates more lift than a wing at a lower angle of attack.
Pushing more air down, right?
When an aircraft begins takeoff, its wing produces no lift because there's no air flowing over it. However, as the aircraft's speed increases, the wing generates more lift, and when the pilot increases the aircraft's angle of attack, the plane lifts off.
Cool.
The next time you're flying in the sky, you'll appreciate how an airplane's wing is lifting you to your next destination. Happy flying.
All right, that's pretty cool.
For more information on this topic and many others, please visit.
Yeah, okay, good. Yeah, cool. Okay, so again, this is just a little bit more information. You don't have to write this down though. I guess it'd be kind of cool to maybe like draw a little picture of this if you want to. So the wing is able to lift airplanes. As the wing slices through the air, it pushes the air over top and under the bottom surface. The curved shape, this is really the key thing. The curved shape, or the aerofoil design, is designed to cause the air to move faster over the top of the wing and slower under the bottom, just like that slide, right? It's gonna fly down there way faster. So again, thanks to Bernoulli, we know that faster moving air creates lower air pressure, and then slower, stiller moving air, which would be underneath, has high pressure. So that's causing the pressing up of the airplane wing. This means that there's more pressure on the bottom of the wing. And the higher pressure pushes the bottom of the wing up, causing the airplane to lift. So I just suggest that you maybe draw this little picture again under like the lift, and that's, yeah, that's it. Okay, angle of attack. Okay, you don't have to write this in if you don't want to, but it is still kind of cool to be able to like visualize. So the angle of attack is the angle of the wing relative to the angle of the air that it slices through. So that means the air that it slices through is obviously going in like, you know, this like direction, unless it's like a crazy storm, then it'd be going in different directions, and the pilot has to use their skills to make balance of the plane. But basically, the higher the angle of attack, okay, so the greater the angle, the more lift, of course, because more air is pushing in here and then being directed downwards. And then the lower of the angle of attack, the less there would be lift. So this is also what the pilot is manipulating when they are controlling, when they're controlling if we're in takeoff mode or normal flight mode or going into a descent. So the pilot increases the angle of attack upon takeoff and to allow the plane to lift. All right. Okay, I'll continue going through this. If you want to write this down, you can. This is like extra information, just kind of cool. You don't necessarily need to know this though. Okay, so design of an airplane wing. So the airplane engineers have used their knowledge of Bernoulli's principle to design airplane wings with an airfoil shape. So camber, maybe you want to write this down. This is kind of a cool thing to know. Camber, so the camber of an airplane's wing is the amount that the wing curves. So camber curves from the leading edge to the trailing edge. So we see here, this is a high camber, right? Big curve, big slope. Of course, it's going to create more lift because the air is going to move even faster. And then less camber, less of a slope, is not going to be as steep for the air to go down the slide. So then, of course, the air isn't going to be moving as fast as this one with more camber. So the wings, wings that have some camber produce more lift than wings that have little to no camber. Okay, we should already talk about this question. How does the amount of camber relate to lift? Why? Okay, so maybe you want to draw this little picture in, more camber, less camber, and then say which one would create more lift. And then why, I guess like the why question is super important. Okay, good. Oh yeah, okay, well there's the answer. Okay, so hopefully that wasn't too hard for you guys today. Just a little bit more kind of cool information before we are, on Sunday, we're gonna be learning about drag and then like true, more like aerodynamic designs. And then we're going to be getting into designing of your own airplanes and aircraft. Which should be kind of fun, I hope. And also learning about like the different controls that it takes for an airplane to act, or like a pilot to actually fly an airplane, which is kind of cool too. Okay, good work. So there's nothing you need to hand in today. It's just taking those few extra little notes on thrust, and then on like a little bit more on like the airfoil of the design of the airplane wing. Okay, good job.